Let's take a look at the interface, user interface of LENA. LENA is a lecture notes annotator. So we have here the input language where we can select previously configured languages. Currently I have English and Estonian. So the prescribing the language, input language, will help to improve the performance of the system, especially considering the poor audio quality of recordings sometimes. Secondly, we have course information. Here we can set the title of the course, when it's read, who is reading it, and what curriculums is it part of. So in this example, I'm currently making a test run on the course I'm reading this semester, which is titled Digital Transformation, and it's included in 2 curriculums. Next, the user interface option gives us 2 options, whether to process the lecture audio automatically by doing all the steps in an automated way, and which results in lecture notes and also fact-checked lecture notes. So we have 2 options for that. Either when we want to translate the text to English, whichever is the language from the 100 supported languages. And secondly, when we would want to transcribe the lecture recording into original language within these 100 languages that OpenAI Whisper model is supporting. Then we have an option to go step by step, where we have 13 steps to complete the process in a manual way. First is the audio convert option, which allows us to convert any audio file into a MP3 format. So given the file size limitations of 25 megabytes for OpenAI Whisper model, we could do pretty well with 32 kilobytes per second and with 44,000 hertz sample rate, and using 1 channel, meaning mono recording. So these are the settings which my dictaphone, Olympus dictaphone, actually is recording at. But as also my dictaphone is recording WMA format, which is not supported by Whisper model, so we may want to convert this into MP3 format. So that's why we have this built-in audio converter. And 2 academic hours of lecture. This is a classic lecture. In astronomic hours, it is 1.5 hours. This roughly translates into 20 megabytes of data in the 32 kilobytes per second bit rate. Once we are done with the audio conversion, if we need this, we are moving on to indicating the audio file we want to transcribe. Sometimes when the audio file is over 25 megabytes, then it's needed to be split into several chunks. So this is what the second step does. And once we have the chunks, each of these will be transcribed either into the original language of the recording, or translated into English. And once these are done, one of these is done, the transcription process is initiated with step 4. Once the transcript is completed, we move on to extracting terms and building the base for terminology, followed by concepts, statements, and examples. And after that, we move on to step 9, which is building or generating diagrams to illustrate concepts. So these are based, these diagrams are based on the step 6 concept. So here the concepts sub text file is used to draw diagrams, and later these are combined into a single text file, meaning the concept text and diagrams. And the last step of building lecture notes file is 11th step, where the notes are compiled into a single document, followed by an optional step for fact checking. And the last step is archiving and cleanup. We can also see that each step is monitored by the code. So to keep track what steps are completed and what not. So once the code is initiated, it will be displaying yellow sign or status processing, and after it's completed, it will turn into green text of complete. So mostly we would go with the auto option, which is pretty straightforward. After clicking the button, I will choose the MP3 file of my liking, and hence the completion, hence the process is started. We can see the progress of the process in the status window, which is keeping track of all these 12 or 13 steps, depending on what we use and what we are not using. The optional steps we may not use, showing whether the each step was successful or not. So here we can see that currently the tool is processing concepts. It has finished, there were 4 concepts identified in that lecture. Actually, this was a presentation, not a lecture. It's a conference presentation. And now the tool has moved on to the statements. So this was a short 8-minute presentation, which did not take long time to complete. So the all 13 steps were finished in, I think, in a minute and a half. Let's look at one of the sample outputs of LENA. So this is a lecture from course Digital Transformation, which shows us the metadata at the header, including the class designation, the course, semester, and who read the lecture. And then we have the main part starting with terminology, where we have roughly about 10 terms identified, such as digital transformation, DeepSeek, distilling large language models, OpenAI, API, European Union AI Act, Industry 4.0, large language models, ChatGPT, and democratization of AI. So of course, you may notice that there are a couple of brand names or company names like DeepSeek and OpenAI, but the tool has saw that these are important to also mention in the section of terminology, what is it or what these are. So this is followed by the concepts section, where we have roughly 5-6 concepts presented. Maybe in this lecture there were more identified, because it's a classic academic lecture. So the first concept that the tool identified from the lecture was the cultural bias in digital tools, where we have a short summary of said concept and then ASCII art style box diagram identifying the key thoughts or elements within this concept and their interactions. Let's look at the next one. This is data sovereignty and privacy concerns. Third one is industrial revolutions and technological change, which is a very basic concept. One might even argue we have these 4 industrial revolutions. Why would you need a graph for that? But sometimes it's maybe better to have a graphical representation of concept in front of your eyes to have a better memorization or impact of notes. Let's move on. The 4th concept is the role of distillation in AI development. So this is a pretty interesting concept, which of course is connected to the DeepSeek model, the Chinese model. And let's see how the LLM understood the concept from the lecture transcript. So we have here the resource input, which is the sort of the beginning of this concept. Then we have the training data, which was the basis for the original model GPT-4, and DeepSeek used GPT-4 by employing distillation method to produce their own model, actually to produce their own training data for their own model. This is the association we see here, and then they had their own resource input, which was significantly lower than original model. Okay, yeah, this concept actually is not connecting the concept into the knowledge or the cognitive capacity of the model, but rather to the resource input. So by using a distillation method, DeepSeek was able to produce a comparable model to OpenAI O1 at a fraction of a cost. So we have here a decision making in personal and professional development. 6th is workforce transformation in the AI era, which is idea I'm introducing in the first lecture, representing 4 groups of the working population, how the AI is transforming the working population. So there are builders. These are the ones who can build AI systems, but these are people who know how to code. And then we have configurers who are skilled to configure AI systems, but they are not necessarily know how to build new systems by writing code. And then we have users, which are the largest part of the working population. These are skilled people who know how to use the AI system. And then we have the 4th group, which are the losers, who have failed to adapt to the AI and don't know how to use AI tools. So we have 7 concepts in this lecture, followed by statements. We have 8 statements here, and the first statement is as goes. The introduction and use of AI tools like ChatGPT and DeepSeek have significant implications for data privacy and the global power dynamics of technology companies. Second statement, distilling large language models allows companies to replicate AI models with less investment, but these copies can never surpass the original models in quality. The 4th section is our real-life examples. So we have here mentionings of how the AI has been implemented in real life or other worth mentioning ideas or happenings such as NVIDIA stock impact. This is where I mentioned in the lecture that NVIDIA experienced a significant drop in stock value when DeepSeek was launched. And then we have the OpenAI's journey, short timescale, distillation method that DeepSeek used, and other notes. This is an excerpt from the transcript of the lecture that we just read the lecture notes about. So the class is starting, and I'm starting it. So today we will discuss the digital change. We will have an introduction, and we will discuss the implications and actuality of digital change. This is the part which says, but everybody is speaking of DeepSeek and the stock prices, like NVIDIA lost 1 trillion. And how much they lost? Was it 1 trillion? No, 800 billions. So somebody in the classroom corrected me and said it was 800 billion. So this is the transcript, and what we just read from the lecture notes was a very concise and well represented, well written way of decoding this transcript. A good lecture always is a discussion with students, and hence we see many such places here in the transcript which has an interaction in it, a discussion of ideas. And this of course makes summarization and topic mapping of the transcript more difficult for the AI. But reviewing the lecture notes for that class and several others that I was testing it with, it did a fairly good job. The concepts, the terms, statements, examples were pretty straightforward and really connected to what was discussed in the class. Here is the transcription or lecture notes from another class. And I would like to point out the fact check correction made by the tool. This is the 0.7 of statements. So the statement that I made and is present in this lecture note is as follows. The rapid advancement of AI technologies may lead to increased electricity consumption, potentially reaching the same magnitude as the total electrical consumption of a country like the US. So after fact-checking, the right document is the fact-checked lecture notes, and then we have the black block representing the corrected statement, which reads as follows. The rapid advancement of AI technologies may lead to increased electricity consumption, potentially reaching significant levels that require careful management to prevent environmental impact. So the LLM has brought in the environmental impact thing, but at the same time removed the reference to the US electrical grid. So I went a little bit deeper on my own, and currently the data centers that are used to run AI workloads takes about 5% of global electricity consumption, and all over the world. And when we speak of the US context, it might be 10 years, maybe 20 years when the requirements of the AI technology reach the same order of magnitude as the current total electrical consumption of the country. So I'm not sure why LLM thought that this is that needs to be corrected. Maybe that's because too far-fetched, or the facts do not support this idea yet. Perhaps, who knows? Let's look at the fact check and the original lecture notes of another lecture. Here we have statements 4 and 5. The statement 4 states the European Union and the UK have introduced regulations on AI, highlighting the importance of informed use and the need for compliance before deployment. So that was changed into the European Union has introduced regulations on AI, and the rest remains the same. So for some reason it thought that UK needs to be removed, maybe because this sentence, the original sentence, can be interpreted as the EU and the UK have introduced the same legislation, whereas UK is now legally separate from the EU. So I'm not sure why this was fact-checked out, but let's look at the fifth fact-check, which was corrected in an interesting way. The original statement reads, the Biden administration in the US has developed its own AI regulations, which are considered a lighter version compared to European standards, offering more flexibility for innovation. So this was fact-checked into the US administration in the US has developed its own AI regulation, which are considered a lighter version compared to the European standards, offering more flexibility and innovation. So maybe that's because Biden is not anymore in office. That's maybe why it's called US administration by fact-checked. But there might be more other reasons why LLM thought that let's remove Biden's name from that statement. Let's look at another comparison from yet another lecture. Here we have within terminology transformer model, which goes as follows. The transformer model is a type of neural network architecture introduced by Google, which has become the foundation for many state-of-the-art AI models. So this was corrected into as follows. The transformer model is a type of neural network architecture introduced in a 2017 paper titled Attention is All You Need by researchers at Google, which has become the foundation for many state-of-the-art AI models. So I think that's fairly good fact-checked and improvement, adding more detail and elements of fact into this lecture note. So that's the end of the overview of LENA. You can read more about LENA at koppelai.eu/LENA.